Hello everyone, I'm super excited to welcome you all at our GSCC week number 5. So, it's been quite a week, right? We had the first day with a great talk about Angular signals, then we transited to system design interview, which was also a great talk. And today we're quite in the middle of our extremely great and amazing week of technical talks. So today we have talk about lightning fast AWS JavaScript runtime. But before we start that, I need to mention several facts. So the first one is that, as I said, we are in the middle of our event, and tomorrow you will have a great talk about AI. So yeah, we'll see how it goes, and then we will have on Friday the last but not least technical talk about Vue Transitions API. So that's our plan for this week. And yet one more thing that I want to mention before we start our event today is that we have comments section. So please drop a line if you have a question or if you have any suggestion or if you have something to add to our speaker. And then once this talk is finished, Dennis, who is going to be speaker today, will be super happy to pick the most interesting question, and he will assign a prize for this person. So, lightning fast AWS JavaScript runtime by Dennis, who is a great AWS specialist and in general a super guru in JavaScript. So, Dennis, the stage is yours. Good luck.
Yeah, thank you. Thank you for introduction. Hi, everyone. So let's start. Yep, today I'm going to tell you about the new JavaScript runtime for the AWS called LLRT. But first, let me briefly tell you about myself a little bit. So I'm a lead software engineer. I'm working with the Node.js and React.js, and I'm from the FrontSpot community. And also, I'm an active resource manager, mentor, pre-sale expert, and a small fact that I'm a Rust enthusiast. So let's dive into the topic. And I believe that a lot of you have a question like this, like another JavaScript runtime again. And because of this, I would like to not only talk about the LRT, but also compare it with other JavaScript runtimes and elaborate on why Node.js is not enough for all use cases. So let's start, and let's start with the LLRT. So LLRT, it is a low latency runtime designed specifically for the serverless applications. And based on the repository, it offers up to 10x faster startup time and up to 2x overall lower cost compared to other JavaScript runtimes. So it sounds really promising, but important to highlight that 10x faster startup time doesn't mean that it will be 10x faster. So we will need to check it. And also, as a matter of fact, LLRT is built using Rust, Tokyo, and QuickJS, so quite modern stack of technologies. So let's proceed. And what about Deno in Ban? So here you can see the table of the most popular runtimes nowadays. So there's a Node.js, Deno, Ban, and LLRT. And all of them are built using different programming languages. And all of them are general purpose except LLRT. It is specifically designed for serverless. And what happened with the LLRT? And the answer is right below. So Node.js and Deno are using V8 as an engine. Ban is using JavaScript Core as an engine, and all of them are using VJIT under the hood. And on the other hand, LLRT is using QuickJS as an engine, and QuickJS is not using JIT. So this is where the benefits come from. The benefits, the advantages and disadvantages, basically. So let's talk a little bit about QuickJS. So the QuickJS, it is a small and like quite embeddable JavaScript engine. And the important part that it can compile our JavaScript sources to the executable with no external dependencies. So it's quite nice. And So that's why the difference, that's the most biggest difference between the previous runtimes and the Quick.js, that is can compile our JavaScript. So I prepared some slide, so with diagrams, and here you can see the difference between the start of the JIT compiled JavaScript engine and the compiled one. So the difference is quite big. So we have a lot of additional steps in the JIT. And of course, these steps are really useful for certain cases, but not for all. And because of that, we can eliminate them for specific use cases and definitely receive some benefits from it. So maybe a lot of you might have a question like this: is compiled code always better than JIT compiled code? And the answer is not exactly. So basically JIT is quite nice technology, and it can be really useful, for example, in the web, when we can like optimize our code specifically for the user use cases. And for example, for big computations on the backend, JIT might be really beneficial here. But for example, for Lambda, where we have usually some really small execution time and we need to like answer fast, so it might be not the best solution to use JIT in such cases. So let's proceed with the LLRT use cases. And basically, you can use LLRT for almost every use case, from data transformation, like real-time processing, authorization and validation, and for integration with AWS. And it's almost every use case, but except one, it is an edge computing. We can't currently use LLRT with edge computing, and I hope that it will be available soon. Let's continue to the second part. And the second part, I decided to create a small example with the LLRT. So a simple Lambda workflow where I will parse and validate some query parameters, make an HTTP request, and perform some simple data manipulations to check that LLRT might be used in like general workflow. So I decided to use AWS CDK to check that LLRT can be used with the modern infrastructure as code tools. I use Zod for data validation and also to check that we can use Zod. We can use not Zod, but external packages with the LLRT. I used Node Fetch to check that we can use modern Node API with the LLRT, and just SpaceX Open API to request some data. So I just needed some stable Open API. So which results? So, first of all, this is how the CDK stack looks like. So here, as you can see, I have Node Lambda, then LLRT Lambda, then I create the API gateway and assign these lambdas to this gateway. And the important thing that start with the LLRT is quite easy. We just need to download the construct for the LLRT and just replace Node.js function construct to the LLRT, and this is it. We are ready to go. So it's quite easy, and because of that, it's quite easy to start with. So let's take a look to the function, and the function is also quite easy. So here I just validate the query parameters, then log them, making an HTTP request and transforms the data just to like have some simple data manipulations, and then just return the result. And this is it. It's quite simple Lambda. Let's proceed. And which results I received. So the cold start, it's when we need to initialize the runtime. The AWS needs to initialize the runtime, download the code. And here I have the following result. So for Node.js Lambda, I received something around from 3 seconds to 4 seconds. And for LLRT is something around 0.5 seconds to 1 second. So it's amazingly faster than the Node.js. And the important note to highlight that the span of the Node.js is bigger. So the span is like 1 second, and for LLRT is like half of the second. And it also shows that LLRT is much more predictable than Node.js. And yeah, let's proceed with the hot start results. So with the hot start results, so the result is much similar, but the span of the Node.js is still bigger, something around 1 second and half. And for LLRT, it's something around 1 second for the hot start, but Node.js is still more unpredictable. So let's proceed with the memory results. And for the memory results, I received something like this. So for LLRT, I always received something around 20 megabytes. And for Node.js, the result was also quite unpredictable, but in general, I received something from something around 80 megabytes. But sometimes I received a little bit more, sometimes a little bit less, also shown that Node.js might be a little bit unpredictable here. So let's proceed. And after all this, you might have a question like this. Can we just use provision concurrency? So because of this, I decided to create some simple calculations. Of course, these calculations might be a little bit synthetic. So for this example, I assume that we have like something around 100 lambdas, and it is quite high load system with 1 million requests per month for each lambda, and at least 20 lambdas should be provisioned to achieve SLA. So for Node.js, for example, I will need to use something around 256 megabytes per lambda because we already took something around 80 megabytes, and it makes sense to increase the memory size to 256. It's a quite popular trick to also save the money and improve the speed of the execution of the Node.js lambdas. For LLRT, we can use 128 megabytes per lambda because we took only around 20 megabyte, and I guess 100 megabytes is enough for the execution and for the code. And we can already see the difference. So for example, for Node.js Lambda, we will pay something around $4 per Lambda, and for LLRT Lambda, we will pay something around $2. I used AWS calculator to calculate these values. And the difference already x2, what we saw in the repository and on the first slide. And another point that for Node.js stack, we will need to provision some lambdas to improve the performance. And here's this example is quite synthetic, of course, because we can use different concurrency for lambda, but let's assume that we would like to use x5 per month. And this lambda will cost us $20 per single lambda. And the difference is quite big. So it's something around x10. So the big difference between the price, and for LLRT, we can just skip the provisions step because it is already fast enough. And yeah, because of that, we can save some money. And the difference between the price will be something around, so for Node.js, we will pay something around $750 per month. And for the system built using LLRT, we will pay something around $230. And yeah, the price is quite significant, especially if we take a look at the year price. Yep. So let's summarize about the LLRT. So LLRT is suitable for serverless applications currently. It is already supported essential Node.js APIs. It has blazingly fast cold start. It is memory and cost effective. And it's quite easy to start with the AWS CDK, as we saw. And currently, it is not suitable for general purpose applications like traditional servers, and it's not suitable for huge computations, of course. And also important to highlight, and we should definitely consider this, that this technology is experimental, yes, so it doesn't support the full Node.js API, so we should be really careful with such technologies. Yep, and at the end, I would like to highlight that LLRT is quite different runtime and interesting runtime because it's not trying to compete the Node.js in the general purpose field like Deno and Ban, but rather trying to apply JavaScript to another place like serverless and optimize the workflows for serverless applications. So, yep, at the end, it is another tool in our common toolkit, and we can use it for cost optimizations and to deliver better software. And yes, this is it. Thank you. And if you have any questions, feel free to ask them. Pavel, are you here?
Yep, I am here, and thank you very much, Dennis, for the talk. So actually, we do have some questions for you, right? And the first one is, do you see any chance that LLRT will someday replace our regular Node.js-based servers? What do you think about it?
I guess there is a really huge possibility of it. It's quite nice. We can use it for a lot of use cases, and we can receive a lot of benefits from it, like for free. So yeah, I guess if we will receive the first version, we can definitely use it in our production.
Okay. All right. It was, I assume, the only question as of now as we speak. Also, we have yet additional question for you. So, does LRT have any use case other than serverless? What do you think?
It's quite controversial because we can definitely use it on the backend side, but it is not recommended because JIT might be beneficial even on the backend side because it might optimize our code for specific use cases. And for example, when we have like big data manipulation tasks, or when we have like huge data transformation tasks, it will be beneficial to use JIT runtimes with the JIT. Yeah, because of that, LRT might be not suitable for that. But for example, simple, maybe small backends might be applicable. Why not?
Okay. Okay. I see, Dennis. So we got another question from Alejandro. So this is a nice presentation. What are some well-known Node.js API that LRT currently does not support, which might impact adoption for production-ready projects?
So it's better to observe the repository because they constantly update the LLRT, of course. And currently, there are some APIs like HTTP and HTTPS Node.js API that are not supported yet by the LLRT, but we can replace them by the fetch, for example, easily. But we should definitely consider because it might be a case when we use some libraries that under the hood use models like HTTP and HTTPS. So yeah, we should definitely consider this.
Okay, I see. Thank you for your explanation. Then we have another question from Andre. Do we have a comparison of LRT to Lambda, Edge, Runtime, or CloudFront functions? Do you have any experience or knowledge of this part?
Sorry, could you repeat this?
Do we have a comparison of LLRT to Lambda Edge runtime or CloudFront functions?
No, not yet. Not yet. We can't use it.
Okie dokie. And then, very important question: is it production ready, in your opinion?
We can use it for specific use cases. For example, we can try to, maybe it's not the best idea, but we can optimize our dev and test environments already. But I'm not sure about production because it is still experimental, and it's better to wait for at least first version, first major version.
Okay, fair enough. All right. I don't see any new questions for you to talk right now. So let's, I guess, give our viewers a minute or so, and then we might wrap up the call then. And while we're waiting, any summary that you might want to provide to our audience? Maybe some lessons learned or something like that, while we're waiting for the last question to pop up.
I guess it's quite nice technology that might sometime evolve in something significant. So we should definitely observe such technologies and trying to adapt them. Maybe try to experiment them in the local environments, play with it, because sometime maybe we will use it much more actively in our real projects to optimize.
Okay. I see. Well, it seems that this topic is quite interesting for our architects. So we have additional question from Andrei. So he wants to know any comparison to A2V8 isolates, because simply speaking, Andrei just trying to understand the alternatives of this one.
Comparison with the V8 isolates. I'm not sure truly what you're talking about. How we are there any comparisons with this runtime with the V8 isolates?
Yep.
I'm not sure that there are some comparisons.
Okay. Fair enough. Yet additional questions from Alex. How do you see Node.js future with so many new engines and then correcting himself runtimes?
Quite interesting question, because currently we have already at least 3 big runtimes like Deno and Ban, and the problem with them that they're trying to compete the Node.js, and we might have this situation like with the Yarn, when everyone was obsessed with the Yarn, and then currently the Yarn is almost dead, and everyone's currently using npm again. So we might see the similar situation with for example, Deno and Ban, but still we have a huge communities that are using Deno right now. For example, Supabase documentation build have examples specifically for Deno, and Ban is also quite popular right now. Yep. So it's quite hard to predict what we will see with this, and maybe we will change our runtimes to something like Ban someday. But again, the LLRT is quite different because it's not trying to compete the Node.js, but rather it's trying to implement the whole Node API and just eliminate the V8 part. Sorry, not V8, but JIT part. It's trying to optimize the Node.js for serverless environment, and this is the difference between this runtime and other runtimes that are currently exist.
Okay, yeah, true enough. Right, thank you, Dennis. I don't see any other questions. So now it's super important task for you to pick the question of the session so we can send special prize for this person. Which question did you like the most?
I guess I really like the questions from Alexander, both of them.
All right. Okay, dokie. Then this prize will go to Alejandro. Right. Okay, dokie. Alejandro, well done. And yeah, Dennis, thank you very much for this choice. And yeah, especially thank you very much for your great tech talk. I'm pretty much sure all our viewers really excited, and our upcoming viewers who then will rewatch this recording will also be super excited about it. And we will see how it goes in 6 months or in a year. We'll see how it goes. So from my part then, about in general GSCC week. So today was the middle part of this GSCC week number 5. So tomorrow we're going to have a talk about AI, and then on Friday we'll have our last but not least talk, and then we'll wrap it up. So thank you very much, everyone. Stay tuned and see you tomorrow. Bye.